Here we go. Have a better marker. The slope of the tangent line when x is equal to 0, you could pretty much clearly see that. The slope is 0. Okay, well guess what? If we wanted to plug in x equals, let's say, 1, so y prime at 1. So we have the point 1, 1 right there. Okay, so y prime at 1, you just replace x with 1. You get 2 times 1, which is equal to 2. And so 2 times 1 is 2. That means that the slope of the tangent line right there, the slope is 2. So this is what it means. This is kind of cool because just before today you were never able to figure out what the slope of the tangent line was. What's the slope of the tangent line when x is equal to -2? Well, guess what? You just replace x with -2. In place of the x here, you replace x with -2 and you get 2 times -2. So you get -4. So we get a slope right over here of -4. And that's what that means. Okay, if I went too fast, back up, rewind the video, and check it out. But let's go ahead and do one of these problems. I think the easiest one for me to do would be number 1, but I'm not going to do the easiest one. I'm going to actually do the, oh yeah, don't bother doing 4. Don't do that. I'll do number 3. Number 3 is the most difficult, and I'm going to have you do numbers 1 and 2. Okay, so for number 3, f of x equaling 1 over x, we know then that f of x plus h is 1 over x plus h, and we want to find the derivative of that function right there. Okay, so the derivative is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. Now I know you know that, so let's go ahead and move on. Equaling the limit as h goes to 0 of, we know what f of x plus h is. It's 1 over x plus h. We know what f of x is. It's 1 over x all over h. And I find that still, even in pre-calc honors, AP Calc, that students are a little bit weak in simplifying complex fractions, which is what this is. And I like to go ahead and I like to multiply top and bottom by whatever's going to get rid of my denominators here. Okay, so the whole rest of this part, until we get to plug the 0 in for h, is just all algebra. In fact, thinking about plugging 0 in for h, if we did replace h with 0, you're going to get 1 over x minus 1 over x. That's 0 over 0. So I already knew I had to do something here, because every time you put h equaling 0 into the difference quotient, you're always going to get 0 over 0. It's always going to happen, because if you just look at it here, replacing h with 0, you get f of x minus f of x over h. Okay, so over 0, f of x over 0, so you always get 0 over 0. So we're always going to have to do something when we're evaluating the difference quotient. So when we multiply both terms here in the numerator by x times x plus h, we can see that this term right here, x plus h, is going to cancel with that x plus h, and all we're going to have left is that x. So we're going to have x in the numerator minus, now be careful here, because this denominator here, x, cancels with that x, and we're going to get an x plus h. And the big mistake that students make is they forget to put parentheses around that, and then they also multiply out the denominator. Don't do that, because you want to keep the denominator factored. Okay, you're going to have to do one of these when we get to class next time, so hopefully you're paying attention. So x minus x is 0, minus h, they get that, forget that minus h also. Okay, so you get minus h up top, and you get an h, x plus h on the bottom, and you get to cancel the h's. Okay, so when you cancel the h's, what you end up getting in the numerator is -1. In the denominator, you get x times x plus h. Now don't make the critical mistake here and forget to do limits. Okay, remember, this is a limit. This whole thing is a limit. Okay, the limiting value, what's the intended value? Well, let's replace h now with 0. If we replace h with 0, what we end up getting is, oops, we don't need to do that. We're just going to replace h with 0. X times x plus 0. Okay, so we get -1 over x squared. I think most students in the beginning, when they're learning how to use the definition of the derivative, they forget to just replace h with 0. And it's okay to get a function of x, because that's indeed what we're getting. We're getting a function of x. The derivative is a function as well as f of x. So we had f of x being 1 over x. We have f prime of x, the derivative is negative 1 over x squared. And if we really wanted to, we're only at the 5-minute mark, so I don't mind doing this. We know what 1 over x looks like, don't we? We know it looks like this. And we know that if we were to be asked, what's the derivative, let's say right here, when x is equal to 2, what's the derivative? You should realize here that the derivative, being the slope of the tangent line, is indeed negative. Okay, so the slope of the tangent line is equal to f prime at 2, the slope of this tangent line, right? So where the tangent line hits the graph where x is equal to 2, you just replace x here with 2. So you go minus 1 over 2 squared, and you get minus 1 over 4. So you get negative 1 over 4, and that's our slope of the tangent line when x is equal to 2. Okay, you can see that anywhere to the right of 0, as long as x is positive, you can see that the denominator is going to be positive, and you're going to get a negative slope. So everywhere along this curve, as x is positive, you get a negative slope of the tangent line. That's going to be really important later on. So I hope you enjoyed it. I hope you understand. Rewind if you don't. If you need help, go ahead and try the first 2 problems on your own. And then if you need help, go back and don't leave this. Don't go on to the next videos until you know how to do problem numbers 1 and 2. Okay? Have a great day.